So the about the so the prefixes that you are giving to your customers, they are built like this is your own prefix that is given you by your registry. And then you have IP addresses that is basically your CP address, and you have up to 16 bits there, something like that, that you can use to subnetting if you delegate your prefix. And then you have the normal interface ID. It's also defined that if, for example, if your CP addresses are in private networks, you can cut away the common one, so you don't need to always put the whole 32 bit of your CP address in there, so you can do some kind of address application. So it's basically very simple. You just have your 6RD capable relays at the edge of your core network and 6RD capable CP devices in your customer network. And what it does automatic tunneling over your core network. And these CP devices basically learn everything through DHCP. So what is the any gas status of these relays and so on. And what is the actual 6RD prefix and what is the rest of the how do you what is the length of the dedicated prefix and so on. It's pretty straightforward. Then the so just to say that 6RD is already deployed, so people are using it. Class stack live is the kind of that has the background coming from Comcast, and it's starting to run out of addresses in your core network. So this allows that you migrate your core network in IPv6 and then you offer IPv4 services on top of this IPv6 only core network. And this again, like the 6RD, this is based on tunneling. And so you have your cross-stack live with their home router before, and then the other end on the edge of your core network getting internet is IFTR, which is basically a cross-stack line with their huge network. One of the kind of neat things called the difficulties of this technology is that it actually makes the IPv4 number meaningless. It doesn't really matter what you put in there. Because what these cross-stack like home router and this networks are interested in, they are interested in the actual tunneling, the IPv6 tunneling the identifiers that runs below the IPv4, so they base all the state and stuff on those other identifiers, so it doesn't matter what is your IPv6. So you can do a solution that for every customer you give the same IPv4 address. So and if you also offering IPv6 services, you can route that, of course, natively in your IPv6 connection. So there's a 4 flavors of it. So and one of the so they're going to reserve certain addresses so that they can CP devices or routers can, if they need to initiate some traffic towards the networks, they can use this certain address range. So here's a simple example of DS-Lite deployment. So internet, then you have your huge mailbox and DS-Lite with your IPv6 home core network, you handle everything there with your home router, and all this mapping and all this state keeping is based on what is your tunnel identifier. If your tunnel identifier is the IPv6 addresses of the not 64 is not about the. I'm going to go a bit over time. I hope it doesn't matter.
Well,
5 minutes.
That's okay. You started 5 minutes late.
So the NAT64 is not about, it's not tunneling, it's a translation solution. So what it allows, if you have an IPv6 only network and you need to contact the services that are in IPv4 internet, then you would use this technology. There are two flavors of it, with the small differences on how these things work is that you have stateless and stateful IPv4. And basically in the stateless mode, all these nodes that are able to connect from the IPv6 only side to the IPv4 internet, they also have IPv4 addresses. In a sense that they are from the IPv4 side, you can identify the IPv6 node using IPv4. So you need to have IPv4 addresses even if you don't really use them. And the stateful mode is more like it behaves like a normal map in a sense that the IPv6 nodes in the IPv6 network, you don't need to have an IPv4 address. You can share one address among a bunch of IPv6 nodes. And NAT64 is going to be used bunch of different addressing formats because somehow you need to be able to you need to synthesize an address for IPv4 node in the IPv6 network. You need to somehow address those IPv4 nodes. So they came up with these 6 different types of addressing how you can actually name an IPv4 node in IPv6 network. And in a stateless case, you basically use these type of addresses. In a stateful mode, when you address an IPv4 node in IPv4 network from IPv6 side, you are basically going to use this kind of. You have a well-known prefix that is initially routing all your traffic to this NAT gateway. So great care has been made that this is completely 4291 full address. And these the small details, the well-known prefix is something that doesn't screw up your text house. And in order to NAT64 to kind of work properly, you need to do something with DNS. Because and then you have DNS64. It basically provides to your service that whenever an IPv6 node queries a name that does not exist in IPv6 DNS space, DNS64 is going to ask for a record and synthesize your what a record. And in that sense, the IPv6 only host is able to initiate a connection towards the IPv4 node that eventually goes through this NAT64 mode. So this is there's actually three different deployment scenarios how to make this DS-64 work, but this is the kind of most common one that you have a recursive caching server in your site that you're going to use. There's a nice diagram how it actually going to work. So your IPv6 host is asking for certain domain close to your 64. It does an internal checking that it doesn't exist in its own cache and so on. It asks for the internet, gets a response, asks the well-known prefix in the address and just what they record and returns the those IPv6 host, make a connection towards this address, that gets routed always to the NAT box. This one does what NAT does, but also from IPv6 what we for IPv4 and so on. So this is a basic way of doing it. So in this way you can have an IPv only network almost transparently going to IPv4 network. So as a summary, so the IDF is now working for these three solutions. 6RD is already deployed. The original version, the IDF version is now very late in the pipe, going to for last call and so on. NAT 64 and even 64 is all about to be finalized. They are still in the working group. And this DS-Lite is also about to be finalized. They are still in the working group, but they're already getting done. They are for different types of deployment scenarios. And basically the push for the new technologies have come from the cable and DSL operator needs. Several operators might need different type of tools, or they might be using these. You don't know yet if they are going to use any of this. And it's to be seen whether these actually, any of these